today's video, I'm going to cover 1.6, Rationalising the Denominator. So, there's a couple of rules you need to know to rationalise the denominator. If a fraction is in the form 1 over root a, how to rationalise it? You multiply both the numerator and the denominator by root a. So basically, we would get root a over root a times root a, and if we multiply the root of any number that's the same, so like for example, if we had root 8 times root 8, the rule is that the roots will cancel out and we'll get 8. So basically, if we times the square root of anything with the same number inside, it will just result in the number on its own. So yeah, it will end up with 1 over a will be the answer to that. The fractions in the form 1 over a plus root b, how do we do this? We multiply the numerator and denominator by a minus root b, and that is called the conjugate. Basically what that does is it cancels out part of it. So we would only get a squared plus b, minus b, sorry, in this case. Because basically if we would multiply this out, we get a squared minus a root b plus a root b minus b. So the a root b's cancel. And finally, for fractions from 1 over a minus root b, we would just multiply the numerator and denominator by a plus root b. So same thing, conjugate. It's the same logic. We cancel out part of the thing, so we just end up with a and b on the denominator. Sorry, so no surds on the denominator, which is that's the end goal in rationalising the denominator. So we've got some questions here that we can possibly do. First question, 1 over root 2, so we're going to have to use this rule here, 1 over root a, to rationalise, multiply the numerator and denominator by root a. So a in this case is 2, so we will just times this by root 2 over root 2. We have to multiply both sides, not just root 2 on its own. We have to multiply both sides by root 2. So 1 times root 2 is just root 2, and then we use the same rule again that we looked at here. Any number, if we have multiply two numbers and we've got the same number inside, the square roots will cancel, we'll just get the number. So we get root 2 times root 2, which is just 2. So we get an answer of root 2 over 2. Question D, root 3 over root 15. Now, we've got two surds on the numerator and denominator, but it's the same thing as before here. It's the same rule. We want to rationalise the denominator, so we want to get rid of this square root. So in order to do that, we're going to do the same thing, times by the square root of 15. Whenever you're doing this question, just try to think, how can I make sure there are no surds on the denominator? And the only way to do that would be to multiply by root 15. So root 15 times by root 15, which would give us 15. And root 3 times root 15 is the rules that we looked at previously. We multiply these together, we get root 45. And root 45 can also be simplified because root 45 is root 9 times root 5, right? So we can also simplify that as root 9 times root 5 over 15. And we know that root 9 is just 3, right? So we can also rewrite that as 3 root 5 over 15. Last step, we can cancel out parts of this because 15 is a multiple of 3. This is obviously a multiple of 3. So we get as our final simplified form root 5 over 5. And there we go. That's our final answer. So just try to make sure to cancel out and make sure that the denominator is with no surds. Now we've got a very challenging, or more challenging question 3 minus 2 root 5 over root 5 minus 1. So we're going to use this rule here, multiply the numerator and denominator by a plus root b. So do 3 minus 2 root 5 over root 5 minus 1. And we're going to times that by root 5 plus over square root of 5 plus 1. So this is just the conjugate. We're cancelling out all the square roots, so we'll just get rational numbers as a denominator. So 3 times root 5 is 3 root 5. 3 times 1 is 3. 2 root 5 times root 5. So basically, how to multiply this? Well, if it's root 5 on its own, we can imagine that there's a 1 here. So minus 2 times 1 is minus 2. And then root 5 times root 5, well, the roots cancel, you just get 5. So minus 2 times 5 is just 10, right? So minus 10. And then we have the minus 2 root 5 times by the 1. So minus 2 root 5. On the denominator, we have root 5 times root 5, which is just 5. Root 5 times 1, so it's plus root 5. And then minus 1 times root 5, which is minus root 5. And then minus 1 times by 1, which is just minus 1. Now, see, we've got the root 5 and the minus root 5. These will just cancel. And then we can also simplify this. 3 minus 10, that is 7. So, and also, last one here, 3 root 5 minus 2 root 5. That will just give us root 5, because in these cases we have the same number inside the square root. We can actually minus them. So we get, I'll just write it over here, root 5 minus 7 over 4. And it said it wants it in p plus q root 5, where p and q are rational numbers. So we can write it as minus 7. We can just flip it around, by the way. Same thing. Plus 1 over 4 root 5. Now, you might be wondering how I got that. Basically, because we've got 4, we've got the common denominator, we can split it into into root 5 over 4 minus 7 over 4. And then I just flipped it around because it wants another one p plus q root 5. So I just flipped it around to get minus 7 plus root 5 on the numerator. And then we'll just split them up into 2 fractions because they're all going to be divided by 4. And then obviously we could also write it as root 5 over 4, but because it said q, I would just put it as 1 over 4 times root 5. That still gives us root 5 over 4. And that completes chapter 1 for A-level maths. So thank you very much for watching, and I'll see you in the next one.